my gratitude to Negi Saab, Oza Saab, my seniors for giving me an opportunity to speak here on this stage. I will speak largely, I was guided by Oza Saab to speak on certain topics. I don't know how far I'll do come up in his expectation, but I'll just try to make a presentation on this thing. It will be a little longish because pipeline integrity as such is a huge subject that cannot be covered in 15-20 minutes. We'll try to get into the core areas. Why is integrity? What is integrity? And what is the technologies, as you were telling, PIG and all those things. So there are two parts to it. One is management and other is technology. And like in every sphere of engineering and this thing, but management has to be there. Without backing of management, it's not possible. So let's see how we go about that. You see, the pipeline integrity management system can be defined. This is a very important sentence, leadership-driven approach to direct, plan, implement, verify measures, and continuously improve. What is to improve? Improve the integrity of the pipelines to protect people and the environment. Our primary objective is not making oil reach from this place to that place. The primary objective is to reach it safely without harming human, environment, and other properties. And second objective is to deliver it reliably, and the quality of the product, to ensure quality of the product. So safety and reliability both are the parts of integrity. Now for achieving that, there are certain elements. I will not go into details of this. This is not the place to discuss. PIMS policy and commitment, PIMS planning, implementation, conformance and compliance because of compliance verification like what YSD does or PESO does, and plan, again for the oil gas companies to design, and management review. Now these plan, do, check and act. That makes a cycle. And this cycle has to be followed. So if we go to the next slide, you see this is the cycle. It's a continuous process of the improvement has to be continuous. Now, and these are some of the points which we have to attend. Again, I said I'm not going to detail, there are a lot of things to cover. But on that side, the decreasing integrity status of a pipeline may create decreasing production and operation conditions. Consequently, the reduction of the overall company's income would reduce the ability to improve both operational flow and integrity. If your business is down, if your integrity is down, today or tomorrow your business will be down. And if your business is down, all the company itself is affected. So that is the linkage between pipeline integrity and the rest of the organization. So now, as I was telling in the beginning, a pipeline integrity management program. Now, what is a program? A planned series of future events or performance. Planned series of future events and performance or future performance. Hence, an integrity management program can be defined as an engineering sound process to manage the integrity of a pipeline through the identification, susceptibility, assessment, prevention, mitigation, monitoring of the risk to protect people and environment. Again, people and environment, providing a reliable service to owner, operator and customers. So all these elements are to be captured: identify, assess, mitigate, prevent and monitor. So these are the 5 Panchamrit जो मोदी साहब बोलते हैं. हमारा इंटीग्रिटी का ये पंचामृत है. Now what is pipeline integrity? To maintain and monitor pipeline systems. A simple definition. इतना ऑक्सफोर्ड में जाने की जरूरत नहीं है. In safe and reliable condition. Now why integrity management? Required for meeting the above 2 factors: safe and reliable conditions, and What is pipeline integrity program? A written action plan. जैसे PNGR में बोलते हैं आपको PIMS document होनी चाहिए. So that is a written document has to be there. Without that, nothing can be achieved. You know, because it's a complex subject, you need to write something. Now, this is the PNGRB के regulations है, guidelines में. I have just copied that flow chart from there. How one should go about this thing. It's an elaborate guideline. You know, so if you follow this, they insist that you follow. And today PNGRB is a very powerful body, and we better follow this. And we have been following. All the oil companies have our PIMS guidelines. IOCL has, GAIL has, HPCL, BPCL, everybody has this. And all of them are following this. It's a nice thing that they have given some standard guideline. Otherwise, I do something, you do something. That scenario used to prevail, maybe a decade back, but not now. Now, I'll show you a graph, you know, why that will explain why it is important to have an integrity management program. कोई भी काम करें को फायदे होने चाहिए. So you see, in some ILI, it detects a dent of 6%. And another case, a dent with only 0.2 mm gauging. Now you see the difference, you know, you see the life cycle of the pipeline, if there's a dent, 6% dent, it's 10,000 pressure cycles, which may come in 5-6 years, because only 5% variation in pressure is considered a pressure cycle. But if it has a dent of dent is added with 0.2 mm gauging of metal, only 0.2 mm. How much it falls? 7,000 or 6,000 is the total cycle fall. So your lifetime of the pipeline will be reduced by this much, from 10,000 to 4,000, 3,900. Only if there's a variation of 5% is considered as a pressure cycle. So effectively 5-6 years you will lose. You know, and your pipe will fail early, 5-6 years early. So if you want to avoid that, better you do pipeline integrity management. You know, without that, such kind of evaluations cannot be done. API 570 is the standard which says how to evaluate dents. And fatigue failure, well, let me clarify one thing here. This is specifically for oil lines. Gas being a compressible liquid, fatigue loading in gas lines are very limited. You know, it will not work out for gas lines. This is for liquid lines, where the non-Newtonian fluid. Now, another this thing is planning of integrity management. Now, I plan, you see the diagram above, my existing pipeline is red, blue, those lines. Now, there is some trouble in that pipeline. I want to replace that line. Now, it's easier to say replace. To replace, you need ROW, you need all these things and all full process, you know. It's very cumbersome. So I have decided that in dotted line, I will lay another pipeline and discard the damaged line. The damaged line, the red spots are all damages. Now, who will decide that? Your engineers cannot. Engineers may propose. Ultimately, your management has to decide. So combined functioning of management and the engineering group will result into achieving this, ultimately, finally, removing it. We are finally laying the pipeline in yellow, this thing. And why? To improve safety and reliability. We must remember, these are the two pillars of pipeline integrity management. We will replace, we will spend a lot of money and trouble to achieve this. Now, ultimately, this is a case where it was really replaced. You can see how difficult the job is. You can see that dotted line on the right-hand side top corner, and this has been actually executed. Now comes a little brainy stuff, where you require, because I consider if you want to go into the depth of all those things, you require a little bit of cerebral activities. Now, everyone knows that integrity is ensured against threats, and we have threats, common threats like corrosion, material defect, mechanical damages, etc., etc. But the issue is, there's a very good news for the pipeline industry in India. when we joined, Mr. Oja is here, he will vouch. The main problem was corrosion. Every day there used to be one leak here and other leak there. You know, from that stage, we have come out. Today there is hardly any leak in the entire network. The problem remains is that third-party activity with malicious intention. I mean to say pilferage. That is the threat today. Or third-party damage, because the country is getting industrialized and a lot of industrial activity go on, and sometimes people carry out digging, etc., without considering presence of pipelines, and they damage. It's happening. More the country develops, more will be the third-party damages. You know, in Western countries, this is the only way of failing a pipeline. In India also it is becoming the pilferage and third-party activities. So we have come out with the corrosion and other problems. Now, this is the same thing. These are some of the cases of failures. How severe it can be. I am putting these photographs, you see, just to show how severe it could be, these failures. You see, the left-hand corner, you see, why there's a big dent, you know. Now, this dent has occurred because there's a rock there. On the rock, we have kept the pipe, and it resulted in this thing. This is a carelessness, you know. There's nothing to do with natural this thing or cause like corrosion and all. It's just a carelessness. And this is another example, you see, where the pipe got buckled, you know, because of poor construction practice. On the other side, on the washout is a natural phenomena, and every year we face this. So there is always a struggle in the company, whether to lay a pipeline on open cut, or now we have HDD. You know, but then every place HDD is not desirable. When there are cheaper engineering solutions, why should we go for HDD? You know, but then the tendency is to do HDD and get rid of all these problems. And then on the right-hand side top, you see a damaged pipe. This was due to a bomb blast. Somebody kept a bomb below the pipeline to damage it, and it actually did damage the pipeline. This was somewhere in the northeast. But then this is a real issue, because security threats are a very, very major threat to the nation, and oil pipelines are extremely vulnerable. Even 2 months back, there was a newspaper report that government is monitoring some information which is floating on this thing market, that there is a group who tries to damage the pipeline. So this could be a very serious this thing. And the other photographs are of pilferage, you know, which is basically a socio-economic problem. And there's a cat and mouse game. We go and catch them, and they do pilferage some other place. It goes on. Now let us come to what Oja Sahab had requested me to speak about metal loss, ultrasonics, and all those things. I have a small case study also at the end. Now, we all know there are common two types of metal loss tool and crack detection tool. There are other tools also nowadays available, but pipeline community in India especially, we know about these two tools. Now, there's a thing called EMET, you know. EMET, because the ultrasonic tool cannot be used for crack detection in gas pipelines. So gas pipeline either has to use MFL or EMET. Now MFL is not considered very good for crack detection. You know, so what do gas pipelines do? They opt for EMET. So these two classes of pigs are commonly this thing. But then it looks very fearsome, you know, photographs, complex mechanical devices and all those things. It used to be, MFL used to be a complex device, maybe a decade back, but nowadays we have solved the mystery, and there are a lot of MFL company, even in India, who are designing and carrying out MFL. It is no longer a black box anymore. Then these are some of the components of MFL. See, once upon a time I was involved in designing of MFL tool in IOCL R&D center. Now, at that time everything used to be imported. Everything. you see the cables, joining cables from modules, these also has to be imported. But nowadays, everything is available in India. Pigs are being made in Delhi, and there are very good people who can design beautiful pigs, and a lot of MFL pigs are made in India. I think Bikram also has a project of developing MFL pigs. Now it's no longer a black boy. UT, yes, still we have some distance to cover. UT tools, very interesting. There are two types. One is compression wave. The top photograph, you see the straight waves go straight and come back straight, and the same sensor will emit the waves and absorb the waves, So, these tools are good. This mechanism of UT is good for measurement of thickness loss. What about cracks, For cracks, you have angle beam probes, Those who are in NDT segment, in every oil industries, maybe in refinery or petrochemical plant or other areas, they are very familiar with UT technology. There's a thing called angle beam probe. Now, it is cut at a particular angle, and it will release the wave in that angle and come back. It comes back to the probe, or there is another device, pitch catch, they call it, wherein there are two probes. One releases, the other absorbs. But nowadays most of the people are going for single probe process, and that can detect cracks. Very easy to say. It's extremely difficult. We'll see later how difficult it is to detect a crack. On the body, maybe you can detect, but the cracks are unfortunately mostly on the welds, and it is extremely difficult to detect cracks on the well. And that is why I included a case study which says we could not detect, and what we faced subsequently. Now for selection of ILI tool, just don't depend on the vendor. Vendor comes and tells you, "Ki sir, hamara paas to badhiya hai. We are one of the best in the world, and all this thing. We'll do MFL, and you do." Please educate yourself. The company fellow has to be educated. Otherwise, how you will manage that contractor? Because he is in that field. He is supposed to know more than you. But if you give up, you're telling that I cannot match this thing, then you'll end up in a lot. He will realize that and take you for a ride. Will charge much more. Today, the cost of MFL maybe in India maybe 1.5 lakhs a kilometer for a standard pipeline, say of 18 inch, and the UT will be 2.5 times that, and sometimes it will be 3, sometimes it will be 4, depending on the type of UT tool and the scope of work you have given. So you should know. You should know what to look for. First of all, what type of pipe you are having. Now, ERW pipes, there could be two types, low frequency and high frequency. And the low frequency has a history of seam failure all over the world, in India, abroad as well. India, fortunately, nowadays, nobody makes low frequency ERW pipes. We have our own pipelines, IOCL, BKPL, Haldia, Moregram, all these are low frequency. Because at that time, high frequency was not available. Subsequently, the new ERW pipes are all high frequency. Low frequency pipes are not accepted for oil sector anymore. Now, what you will do? For a low frequency pipeline, if you want to, that there is a tendency to fail from the seam joint, weld seam, So you cannot do a normal MFL, metal loss MFL. It will hardly tell you anything on that. So you have to do a CMFL kind of thing, where the lines of force will be circumferentially oriented, and it will cut the weld, and it will reveal whether the weld is properly joined or not. So that much you should know. Or you do an UT. UT is very expensive, So you should know your pipe first. Then you should know what is your problem. It has been my experience that we go for, the best vehicle available in the market. If money is somebody else's, we say, "Hum to Mercedes kharid lenge, hamari paisa to hai nahi." So that's what happens, So aapko kuch seekhne ka bhi zarurat nahi hai, pay more money and buy a Mercedes. You remember when once upon a time we used to drive Fiat cars, and almost each one of us of our age, my age, Oza Saab's age, we knew how to dismantle that car and how to this thing. It was so troublesome, But today, vehicles, you just don't know. You just press the key and this thing. But here you have to know something, you know. So selecting a tool. Now, normal corrosion, how will you know? You can know from your CP history. You can know from your failure history, previous history, that my line is having some kind of corrosion, not very severe and all. Why don't I go for a low resolution tool, which somebody may offer you for 75,000 a kilometer? Instead, we go for high res, you know, without knowing what is high res, and end up paying, say, 1.5 lakhs a kilometer, double the cost. For a 1,000-kilometer pipeline, you can understand how much you spend. So it's better to know what kind of corrosion, what kind of problem you are having. You know, that is another thing, whether you have pitting or general corrosion. So all these things you have to know, you know, before going for selecting a pig. Then comes what you are transporting. Suppose you are transporting gas, you know, and you have no history of this thing. In India, gas lines do not have a history of stress corrosion failure. In some of the foreign countries like USA and Canada, they have these cases of stress corrosion failure. Fortunately, we do not have that. So what can happen? GAIL pipelines, it can have corrosion, normal corrosion only. And possibility of corrosion in gas line is extremely low. Because if you control the quality of gas, if you pump dry gas, nothing is going to happen. You know, I have seen recently, I have reviewed a ILI report. After 25 years, that pipeline was running for 25 years, gas pipeline, not a single case of metal loss has come which is above 15%. There's no corrosion at all, that means. You know, neither external nor internal. So gas pipelines are very safe unless you do great wrong with that thing, you know. Normal, follow the procedure. You never have to do an ILI even in gas lines. Only you can do ILI to detect dents or some sort of other anomalies. For corrosion, no. If your CLP coating is holding, that CP will show you. And if you are internally you are picking once in a year or so, whatever it may be, nothing is going to happen for gas lines, you know. So in that case, why should I go for hi-fi tools and EMAT and all those things to spend just like that money, you know? So I normally use a low resolution MFL. And gas pipes are generally higher wall thickness, and some 15-20% metal losses hardly going to make. If it is an internal corrosion, you see why 15% metal loss has taken place. If it is external corrosion, definitely there is a coating failure, which is even easier to detect, you know. So commodity what you are pumping, you should know. There are very good standards, you know. There is a standard UKOPA, you know, United Kingdom Offshore Pipeline Operators Forum. UKOPA freely available in internet. You can download free without going for an expensive API standard or your ASME standards. You know, you can get this free, and all these things are available. So you know what corrosion is there and what tool is to be used. Then you see what is most important is what the vendor promises. The vendor should promise, now everyone promises, probability of detection 90%, depth sizing accuracy 90% certainty, width sizing accuracy 90% certainty, and length accuracy 90%. All this 90%. But no MFL tool can detect metal loss depth-wise more than 80%. You know, they say our attempt is to go for 100% accuracy, but we have seen more than 80% nobody does. Another very important thing is that if you are going for a ILI of a pipeline whose thickness is, say, a gas lines or offshore line, where the thickness is more than 20 mm, please do not use MFL tool. Why? Because MFL detection accuracy is in terms of percentage metal loss of wall thickness. So 0.1 T means 10% of the thickness. So for a 25 mm thick pipe, you know, 2.5 mm, he will not give very certainty. It could be 6 mm plus 2.5, or it could be 6 mm minus 2.5. So for offshore pipelines, it is preferable to use UT tool, which gives it accuracy of 0.1 mm or 1 mm. You know, UT is very accurate. So these are some of the things what we should keep in mind. All the standards and these things are available. everything is available, POF, this thing. Only you have to familiarize yourself with that. Now, if one of the very, very critical this thing is, I promise you, I will detect with 90% accuracy. 90% probability of detection. I never tell you that how much I am not going to detect. कितना मैं पकड़ूंगा वो तो मैं बता देता हूँ, कितना छोड़ दूंगा वो मैं नहीं बता रहा हूँ, और क्या क्या छोड़ा मैंने. Maybe those are very severe. Now, how to ensure that your tool has detected all the critical anomalies? That is where एक भी छोड़ दिया और वो critical निकला तो आपके सारा मेहनत बेकार हो गया. So how to ensure that? For that, there are techniques of dig site verification. How to select location for dig site verification is given there on the basis of ERF. More than one such this thing, and one must visit with the weakest point in our system is that if say XYZ company, I am not taking names, committing that मेरे tool आपको वहाँ भेज रहा हूँ, I have done calibration. Have you seen the calibration? Did a member from IOCL or GAIL or HPCL, did he see the calibration? The tool calibration, they call it pull-through test, is the most vital thing, and every pull-through test, whether it is done in India or in Germany or in Russia, people from the owner's company must be present. If you are not present, then put a very reliable third-party inspection agency, DNV, etc. Because if the calibration is not proper, you don't get a proper report. And you never know what, आप pipe के अंदर जाके देख नहीं सकते हो, सही दिया है, गलत दिया है. So pull-through test is a very critical this thing, and then ERF, this verification, field verification. These are two very important this thing. Now, these are the specification of standard MFL tool, very much available in the market. 1.5 lakh रुपया का वो है per kilometer rate, and these are the field verification results you see of such tool. You know, this is 3.2 mm. It is this thing, and actually they have found 6.45. These are all within predicted limits. So such kind of good tools are available in India nowadays. So as I promised, we'll do quickly we'll do one crack detection case, live case. You see, because I'm crossing time, so I'm skipping some of the slides. You know? This is the case. This is a IOCL crude oil pipeline of 1,100 kilometer, 22-inch diameter. You know, we faced within 6 months there were 5 seam ruptures, which are very, very serious type of failure. Fortunately, no fire, no this thing was happened. But then it was very, very strange that why 5 failures took place, and at the failure spot there were no corrosion, nothing. And before that, there was no history of failure, no coating damage, nothing absolutely. You know, but then pipes are opening up. So what we did, these are the 5 locations. You see, and that then we hired, after the first failure, we hired NDT services, who are one of the top at that time of ultrasonic inspection, and hired the best pig. For a pipeline, we spent 15 crore for inspection of this pipeline, you know, which was the highest in those days, maybe one of the biggest order in the world. And they did inspection, they did something, they did it with all seriousness, and after the first failure, and second failure, we did the inspection, and after that inspection, after the reports were available, after field verification, 3 more failures took place. So it was very clear that this tool could not detect what is the problem. Not on this. You see, these are the failures. Straight opening of the seam. And all the failures are below the MOP. You know. So we tried our level best to find out why it is getting failed. Previously, on that line, before the failures, we did MFL survey of that pipeline also. And there was no corrosion, as I said. No, you see all are red are below the line. You know, all are in acceptable region. So this was a mystery for us. So we went to all sorts of, let me tell you, we went to all the metrological laboratories in the country. The best of best, NML, IIT Chennai, you name anything. We went to every place. Some people said because of this, some people said because of this. Nobody could conclude. What happened, and I will tell you next. We tried in our latest equipment, we sent abroad. We sent our samples abroad, in USA, in Netherlands, both the places. We tried, IOC management was heavily supporting us. Well, do jo karna hai karo, but we must know what is the reason. You see, these are some of the only thing we found out, that there is some misalignment in the weld, which those they say out of limit, but it is not. I believe it was not, because the pipes were made, the pipes made from various mills. You know, some of the failed pipes were milled in Mexico, some were from Brazil. You cannot say is mill ka sara mal kharab hai, because various mills, alag mills ke bahar bana hai, and we found out inspection report, everything was acceptable. And inspection was not by any Tom, Dick and Harry like me. It was done by very good people, you know. Still, it was a mystery. कुछ भी कोई नहीं बता पाया हमको किस लिए fail हुआ. You see, these are the kind of cracks, but all failures are similar. All are opening from the weld. You know, weld of submerged arc welded pipes. You know, sometimes its irony is that, you know, Rajkishore is sitting here, will agree that pipe, as far as pipe is concerned, we always say spiral weld pipes are not better, straight seam pipes are better. In our case, our experience for last 50 years, not a single spiral weld pipe has opened from the seam. All whatever has happened to the long seam made from abroad, not by any Indian mill. You know, spiral weld pipes are not, I firmly believe these are not going to fail. Spiral weld pipe will not fail from, well, I think there was a big history, Negi Sahab knows, that GAIL sent a big team of engineers all around the world, because GAIL had specified spiral weld pipe, straight seam pipe, and somebody said spiral, I don't remember the story, and then government of India agreed that yes, spiral weld and straight seam are same. Instead, we could have told him, without spending a single paisa, IOCL has the oldest pipeline, spiral weld pipeline, Salai Mathura pipeline. There was not a single bust because of the weld. And this was the imported pipes, straight seam, so many busts. So let us not go into those. That is why I say it's very important to have your experiences, you know. So these are all failed samples, and all sorts of tests we have done. All, you name it, anything we have done. I'll tell you what has happened finally. Interesting, just see. These are various failures. Because of paucity of time, we are not going to discuss. Ultrasonic tool has given this kind of report. We have done a lot of repair, but still failures continue to happen. And then the party, very honest people, you know, they said that orientation of cracks prevents detection by UT shear wave tool. And that was the conclusion. The geometry of the anomalies growing within the pipe wall represents one limitation of the technology for a proper depth calculation. These kind of defects cannot be detected by their tool. Nowadays, they claim that we have come out with a different variety of ultrasonic tool. This was long back in 2016-17. Nowadays, they claim that we have developed the tool, and they tried very hard. We sent a sample to them also. And they say, now we can, they say. But I am not sure. I am not sure whether this kind of defect can be detected or not. Now you must be interested to know what happened to that pipeline. The pipeline is running well. You know what we did? We replaced 71 kilometers of the pipeline and reduced operating pressure. Because after all our research and all, we found that the most probable reason is operation. Here I would like to pinpoint a very important point. This pipeline was in product service and had multiple point delivery. We changed it to crude service and single point delivery at Panipat refinery, starting from Kandla after 1100 kilometers. Now, whenever you increase or decrease pressure in that line, maybe 74 kg is MOP. After half an hour, you make it 70 kg. Or after half an hour, you make it 60 kg, depending on the demand, you know. It's a common practice in pipeline operation. Somebody says, my tank, I'm changing over the tanks, so it reduces the pressure. Some other station say, my engine RPM is not proper, so I have to reduce the pressure. It goes on, whole day it goes on. You know. There are 10, 11 stations in the line. So there is always a fluctuation in this thing. Now question is, when you're fluctuating, you are fluctuating a column of crude oil, which is very heavy and 1100 kilometer long. So that's creating tremendous impact on the pipeline. You know, this fact we ignored. When we convert a pipeline, we don't look into it. People give an excuse कि ये तो ASME 31.4 से डिजाइन था पहले भी प्रोडक्ट के लिए क्रूड में भी ASME 31 पॉइंट के लिए डिजाइन है तो हमको क्या प्रॉब्लम है so ISD PNGRB everybody says yes agreed ठीक है करो but this is the result you see so you need engineering on every this thing जो मैं कर रहा हूँ उसका नतीजा क्या है so finally what we did we replaced 71 kilometer of this pipeline and reduced the operating pressure by 20%. Since 2017, there is no failure as one did. It's running hale and hearty. So this is the case. It emphasizes so many things. I will not take much time. So thank you so much. If you have any questions, you can ask me now or you can ask me afterwards. Thank you.